Hello, I'm Avery Chung, and I'm from 7407 The Wired Boars. And today we're going to be looking at Team 1757, the Wolverines code for the 2025 Reefscape season. All right, so this is Team 1757's Reefscape code. They have a Python WPI lib command based structure, and it reps a lot of CTRE Phoenix 6 motor stuff very nicely. So this is their robot.py file. So it's like the sort of shell for their robot. It makes the robot object and runs the period loops. Now, there's not a lot of content in this file, and that's because the actual brains of the robot would be found in robot container. So robot container creates, like the actual brain of the robot. It holds all the controls, all the subsystems, the commands, and basically all the bindings, everything related to the robot. So as you can see, it's a lot beefier than robot.py. All right, so moving on, they use a toolbox which can be found in Symtalin. Basically, it's just a convenience layer, so that they don't have to rewrite the motor setup code every time they make a new subsystem. So as you can see here, here's their motor class, their dunder in it, and all the motor code they would need. So moving on, 1757 uses something called motion magic to control their motors. So in a nutshell, motion magic is telling the robot how to move a part, such let's say the elevator, to a certain position smoothly at a certain speed plan. So an example of what that would look like as a graph would be this. So let's say they want to raise the elevator from the 0 to its maximum height smoothly with motion profile. They could define a certain cruise velocity, and it would basically figure out how to smoothly raise the elevator without, fully ramming the elevator into its hard stop. All right, so moving on. 1757 uses a command-based structure. So what this means is, basically, if you can see on our left here, they divide their robot into a bunch of different subsystems. So there's the climber, the drive, the elevator, and so on. And what this does is it defines what physically exists on the robot. So, like I said, it's the elevator, drive, the climber, and they have commands to tell the subsystems what to do and how to do them. So that's such as like drive or intake coil. So how does the robot know when to do a command, or like when to initiate a command? Well, it's there's a thing called the scheduler, which is run once every loop in periodic, and it sees if a subsystem is already running a command and executes commands based on that info. So if subsystem already has a command, it'll just wait for that command to be finished and then execute the next one it has scheduled. So it exists so that we don't send multiple commands to the same subsystem, and that subsystem tries to do two things at once and breaks. All right, so moving on, let's take a look at how a command is structured. So these are their fudge intake commands. So each command is its own class. They have four methods, including the dunder in it. Yeah, so moving on, let's see their initialize method. So in that method, they log that they ran this command. It's pretty simple. Um, and in their execute, they default it to an error message. And that's actually because this class or this command is a parent class. So it's used as like a default for basically all the other fudge intake commands. As you can see here, it's their parent class. So if they don't overwrite the execute method, it'll automatically just give them error message. And yep. So moving on, they have their end method too. It basically runs when their command ends. So what they do is just log done. There is finish method also just instantly ends the command. So if you ran fudge intake dot is finished, then it would just end the command immediately. All right, so let's look at one of the child commands. So this is the score forward uh, command, and you'll notice something's missing. They're missing the and is finished methods. And this is because they just defaulted those or inherited those methods from their parent class. So it's basically like this, it's just hidden. But as you can see, they did overwrite their execute, so it's not going to spit out this crass message. It will do this instead. All right, so let's move on to the actual like meat of this code. So these are the subsystems. We're gonna start with the init actually. So this is their dunder init.py file. Um, they have it empty. This is really optional to use. Basically, it's used as like a packager for all of these different files. So you could import all of these into the dunder init.py file, and instead of importing all these one by one into, let's say, like robot container, you could just import this file. So it's for convenience, basically. Right, so let's move on to their intake subsystem. So their intake uses a roller motor, a pivot motor, and a pivot encoder. They use something called states. So basically, like the intake is idle, intaking, scoring, or like the intake is knocking. Um, and in periodic, the robot will check the state of the subsystem, and it'll move the pivot angle to be and the roller speed to match the state. Um, and the pivot motor uses motion magic to hit the angles it needs to move to smoothly. Moving on to the elevator subsystem. This is their elevator. So they have two elevator motors. There's motor 1 and motor 2. And basically, motor 2 is motor 1's follower. So whatever motor 1 does, motor 2 will just copy exactly. They also use states for their elevator. So like L1, L2, L3, algae, high-low, intake, and manual. So in periodic, it'll also check these states. The robot will also check these states. And it picks a target belt position based on that state. Right. The elevator also uses motion magic to target the target position smoothly. So they would get their position, check if they're at their position, yeah, and they would set their elevator's position. But basically, yeah, they also have something interesting called modifiable constants or modifiable constant positions. And these positions are basically tunable without redeploying the robot, which is pretty interesting. Let's move on to their climber subsystem. So this is their climber subsystem. So they only have one climber motor, but it also uses states like the rest you covered. So they have like tucked, at frame, passive deploy, manual, and nothing pressed. So in periodic, the robot will drive the motor towards whatever target position matches with the current state. And finally, our final subsystem, we have logging. So in their logging subsystem, it does just that. It logs everything they do. So it'll log everything with the driver station and controller info. So button presses, axes, POVs, and publishes the robot's pose and computes 3D positions for elevator and intake arm for visualization. Overall, in the 2025 Rescape season, I'd say the 1757 did pretty decent, being placed 59th out of 896. And yeah, you can see some of their scores here. It's a pretty even mix of wins and losses. Yep, you can see their robot here. And yep. All right, so that about wraps up Team 1757's code. Um, yeah, thank you for watching.